you very much for giving us the opportunity to present the work that we have been doing within the TeraFlow project during well, the first year of the project. In this presentation and demo, I will try to showcase well, the current capacities of the TeraFlow Cloud Native SDN Controller, which is a joint effort that we did all the TeraFlow partners, and well, it's nice to have the opportunity to present what we did. So, well, for those of you that don't know about the H2020 TeraFlow project, the idea is that well, as you might know, current SDN controllers are mainly based on monolithic software, and well, indeed, they inherit the limitations of this kind of software in terms of scalability, flexibility, dynamicity, well, many limitations. And the main focus of the project is in developing and releasing a novel cloud-native SDN controller for beyond 5G networks. In addition to that, the idea is to integrate also functionalities and integration with current NFV and NEC frameworks like well, OSM for sure. Provide flow integration features, service management, network integration, machine learning, basic security and forensics, and multi-tenancy. For sure, if you want more details about the project, we invite you to visit our website. It's right in here in the bottom part of the slide. And well, since, as you know, well, given it's an H2020 project, it's limited in time, and we would like to extend the time this project lasts. So for that, the idea is that we are working on creating an open source group within HCSI. The name of the group is TeraFlow SDN. And the acronym for that will be TFS. And well, we are collecting support from different groups. Well, we think they can benefit from this project. So among others, as you can see, OSM, it's quite interested in TeraFlow. And well, having said that, I will briefly present the architecture of the controller. As you can see, it's a microservice-based architecture with many services that have their responsibilities, and these services are classified into main groups. One of them is the core group, which contains the main functionality of the controller, including things like the context management that stores the information about the different elements that are being elements, resources, everything that is being managed by the controller. The device component is in charge of interacting with the different components in the infrastructure. The monitoring component is in charge of collecting monitoring data. Automation implements some automatic behaviors for controlling the devices. The service component is in charge of the connectivity services that are requested and established in the network. But I will not go through all of them to don't spend so much time. The one that I want to mention also is the compute component, because it brings a normal interface for external systems like OSM to receive some requests, like for instance, connectivity requests. And then we have the second set of components, which is the NetApps block that implements some extensions in the on top of the core components. So, for instance, here we can see things like the cybersecurity functionalities, inter-domain, for instance, in case we want to interconnect multiple instances of TeraFlow, each of them in charge of one domain, for instance. And well, indeed, also we have a web user interface that enables the user to interact in an easy way with the controller. To illustrate in this demonstration what we are willing to show, we will focus on this network service. It's a multi-site network service composed of 2 BNFs, and in each of the BNFs we have 2 BDUs, one for management and the other for data, and they are interconnected by means of an internal network. Then, well, each of these DNS, the idea is that will be deployed in a particular data center. So it will have, in this case, an open stack in charge of the management of the virtual infrastructure resources. And OSM will be in charge of the deployment and the management of the DNS. However, we need to interconnect them. And well, in this case, is where the TeraFlow SDN Controller plays a key role, because the TeraFlow controller here acts as a WIM infrastructure manager, and by means of the WIM connectors, OSM can delegate the connection establishment through the TeraFlow controller. So that's what we want to showcase here. For this demonstration, we will focus in these components that are highlighted in blue. The idea is that, well, as I said, open source MANO will be in charge of controlling the data centers and the deployment of the virtual computation resources, and then TeraFlow will be in charge of configuring the data plane, that in this case is composed of a packet layer and an optical layer. For the packet layer, we have some packet routers that are controlled by means of the OpenConfig data model. And then for the optical layer, we rely on the transport API for controlling the optical devices by means of an open line system controller. The workflow here that we will show when we deploy the network service will be that the open source MANO will first issue the connectivity request towards the compute module, and then compute module will delegate on the service component for computing the path along the network. And finally, the service component will create the appropriate configuration rules for the devices, and the device component will implement these configuration rules in the different components. So, well, having said that, one of the troubles that we faced when implementing this workflow was that in OSM there was some functionality for the WIM infrastructure manager, and at some point when we tried to deploy the thing, we realized that part of the functionality was not properly working. So we had to extend the functionality mainly of the LCM component for identifying when multiple virtual infrastructure managers are involved in a network service, then finding which one infrastructure manager is able to interconnect these VIMs, and finally, if one infrastructure manager is specified, for sure we will use it, and finally to populate the appropriate RO tasks with the parameters inferred from the one infrastructure manager port mapping. I mean, the settings that are defined for the WIM account. So here we can see an example of the network service creation request. In this case, we specify first which are the members of the network service and in which VIM we want to deploy them. In this case, we have two OpenStack data centers, and then we also define some parameters for mapping the networks to the networks that we have defined in the data center. So in that way, we specify which is the management and the data networks we want to use in each of the data centers. Something that we found that was needed at the very beginning of our test was the need of specifying which one infrastructure manager account we want to use. But part of the functionality we implemented is to remove the need of specifying this parameter. And now, thanks to the port mapping information and the new features, OSM is able to automatically identify which WIM is convenient for the deployment of the request. For the port mapping that we specified to use here, it's mainly the one that was already defined in the specifications. We just populated some values here. The idea you see, it's just defining the mappings between the C router and the P router, and defining the bearers and so on. So I will not elaborate a lot on that. And with all this information, the LCM will create the appropriate RO tasks, defining mainly, or the most important parameter that is defined is this SDN ports block that indeed specifies which are the SDN ports that needs to be connected to establish the one connectivity service. And well, with these parameters, as soon as we execute them, in this case, the IETF L2VPN connector, that is the one we use, will generate the appropriate messages for establishing this connectivity. So first it will create the service, then it will add a couple of endpoints to this connectivity service, one for each of the sites that needs to be connected. And well, then it will request the status of the service, and finally, after deleting the network service, it will also delete the connectivity service. This is the workflow that we use it for this demonstration for the creation of the service. You see here that as soon as OSM creates the service, as I said, it delegates in the compute component. The compute component delegates on service to compute path and so on. But here in this first step, it just creates the service and stores the service, because OSM requires a unique identifier for the service. So in this first step, we just create the service to get the identifier, and then we populate the service with the appropriate endpoints. And for each addition of a new endpoint to the service, we configure the appropriate device rules that are needed to establish the connectivity service. And well, for achieving that, we had to solve some different bugs and issues. Majority of them are minor things like typos here and there, maybe some function with wrong parameters. But the big one, it's the one that is highlighted, that is the implementation of this LCM functionality for automating the use of the one infrastructure manager. Majority of them are well, under review. All of them are already on Gifre, but well, the last 4 ones are under review right now. And well, we have some open issues that we would like to address and future work. It's mainly the implementation of service constraints for the VLDs. In this case, for instance, things like capacity, latency, jitter, and so on, because it's something important for 5G and beyond networks to be able to define these constraints. And then we also having a roadmap to implement some other WIM connectors for layer 3 VPN, because I said we use the layer 2 VPN, and also we would like to implement the transport API WIM connector for digital signal rate connectivity services. And having said that, I will continue with the demo. I initially had in the slides to do a live demonstration, but since well, in this demonstration we are interacting with components from external partners, finally prefer to reuse the video we presented last Friday in OFC conference. Also, we would like to let you know that the source code we are using for this demonstration is available on our GitLab repository. So feel free to clone the repository and play by yourself. And also that the demonstration we did at OFC conference is available on our YouTube channel. So feel free to connect there and check the whole presentation with the complete demonstration. I will show here just the final part of the video that I will comment on the fly. So let me now jump to the video. Just a second. I guess you can see now the video.
Yes.
So
Yes.
okay, perfect. So I will start to play. So this is the web user interface of the TeraFlow SDN controller, and you can see here that we have different sections for the different entities that can be managed. And we can also here select which is the context we want to manage. Right now, as it's not populated, there are no contexts. And we can also upload the descriptors for the components we want to manage. We will do that here. We are uploading the descriptors. It's just a matter of saving time and not having to populate everything resource by resource. This is the open line system that we are using for the optical layer. This is the topology. And here we have the open source MANO with the different components. As you see here, we still have no network services that are deployed. We have the two virtual infrastructure management accounts here for the two data centers that right now are empty. We have no instances running here. And we'll refresh here. And also for the second one, the same, we have no instances running. Right now, it populated the context, the topology, the 5 devices, and 4 links here. And we can see here in the bottom part, which is the data plane topology that we are considering. We have 2 physical packet routers that are the ones in blue, and 2 emulated packet routers that are in black. And in the middle, we have the open line system device that is connecting all of them. Here now we see that we have the context that we uploaded. And after selecting it and submit, we will now see that the current context is now admin. So we can go to devices now, and we can see that the different devices have been populated. Here we see the open line system with which is using the transport API driver, the packet router that is using OpenConfig. You see that all of them are enabled. That's the vision of the automation component to bootstrap and enable the different network devices, and well, the other emulated and real packet devices. Here we can check for each of the devices the different endpoints that they expose, and also we can see which are the configuration rules that are already defined and well loaded from the device. For the packet router, we can see here again the endpoints, the settings, and here you can see that for some of these endpoints we can monitor some values, in particular the input and output packets and octets. So that's something we will showcase later also. And well, we have many endpoints here and information about interfaces and sub-interfaces and so on. And well, here we have also the information about the links. I will maybe, it's just a set of links. Maybe I will try to go faster. Right now, here we have no services created. And in Grafana, we will see that right now we have panel, it's loading, we have now the data that is being plotted. It's the traffic coming from some traffic generators that are deployed in the testbed. Well, we here filtered which are the interesting endpoints here to monitor, but we see that we have only traffic on the endpoints that are connected to the traffic generators, but not in the links that are in between of the devices. Here, maybe I can go faster. Yeah, so here, let's go to OSM and we'll create the network service here. Moment, so yeah, create a network service. We use here the multi-BDU network service from Hackfest, and yeah, you populate here the values. We select here the configuration is essentially the one that I was showing in the slide, specifying in which theme we want to deploy each of the DNS, and also the mapping for the network services, sorry, the BLDs. So yeah, after that, we will create network service. A moment. Well, it takes more time here, but thanks that it's a video, I was cutting all the time it takes to deploy resources. So in just a few seconds, it should be done. Yeah, that's it. So here we have the network service that is deployed. We can check here now the instances. And yeah, so we have here the two instances for the management and the data. And let's say here on the other data center. And well, you can see here now in the TeraFlow user interface that thanks to the WIM connector, now we have the two services. You see that we have two of them. One of them in the one on the top is for the packet layer. For the one on the bottom, the tabby, is for the optical layer. You see here it's photonic layer. And well, and the interesting thing here is that for the service, you can see that the different configuration values have been populated. Some of them coming from the OSM WIM account in the configuration, I mean the port mapping. We can see here also that after creating the service, we started to have traffic in between the devices. That's why we have this increase in traffic in the plots. And well, here the second part is now to delete the service. And as soon as we delete the service, again it will take some seconds to delete it. So it's done. So now it will check here that the different instances have been properly deleted in OpenStack, and here in the TeraFlow user interface, you can see that the services have been deleted, and also in the Grafana panel, you can see that now we have no traffic in between the devices. So that's it. That's it. That's the end of this part of the demonstration. Yeah. So and that's the demonstration we wanted to show. And well, to conclude the not working. Well, to conclude the presentation, I would like to thank you for the opportunity. I don't know why. I don't know why it's not working. Okay, yeah. Thank you so much for your attention. And well, if you have any questions, please let me know. And yeah, here you can see all the logos of all the partners on the TeraFlow project. Many of them collaborated in this demonstration with different service components, so microservice components, I mean. So I would like to acknowledge them. So thank you so much. Let me know if you have any question.